Let's talk about pages 20 and 21 in the second piece of Algebra 2. Wow, there are some neat algebra terms in here that may not be familiar to you. One is monomial, binomial, trinomial, okay? And they give the definitions there on page 20. If a term only has one, let's say, I'm just making one up here, x, y squared. This only has one term, so this is a binomial. Let me add, okay? This would be, a monomial, because it has one term. This is a binomial because it's a term plus a term. Doesn't matter what's in it, okay? Doesn't matter how many variables we have. This is a term, this is a term, so it's a binomial, okay? This is a trinomial because I have 1, 2, 3. Same here, 1, 2, 3 terms. So this would be a trinomial. So that's one terminology, and you just label anything with one or more. So all of these are considered polynomials, okay? But we're just labeling whether they're monomials or binomials or trinomials. They're on page 20. Then on page 21, at the top it talks about the degree of a polynomial. And I just want to point something out here that may not be real obvious at first, and that is that we add the exponents, okay, for each term. This one, I'll use a different color here. Two, but we don't see the exponent for x. But you remember, if you don't see an exponent, we can assume it's 1. So this one, the degree, we would say, is 3. Okay? Let's look at this one. What's the degree here? If it's just a number, we don't, that's not a variable, so we don't take any exponents from there. But we take the 3 from here, the 1 from here, so this is 4, and this one is just 1. In a case like this, in a binomial, when we have 2 degrees, we always choose the higher number. So we would call this whole binomial a 4th degree polynomial or binomial. Okay, let's look at this one. 1 plus 3, so this is a 4. This one's just 2. Now what is the degree of just a number? You might be tempted to say 1, okay, but actually anything to the 0 power is 1. And technically this is what we have here. 3 times 1 is 3. So that's why this is invisible. We don't need it, it's gone, but we would say that the exponent is 0. So in this case I'm comparing 4, 2, and 0. So we would say again this is a 4th. Now here's one that's a lot bigger. 3, 2, plus 1, okay? So 6 would be the degree of that term. This one only has one term, but it's 13. And in this one, again, is 0. Now, in looking at all of these, we're going to just take the highest sum of the exponents for each term. So I don't add these together to get 19. Nope, I just say this is the 13th degree, okay? And then at the bottom of the page, we're just going to rearrange the order of these so that the one with the highest exponent comes first, but it says with respect to x, okay? So you focus on the x. So in this first one, I have x minus 3 plus x squared y. So that last term, x squared y, is the one that needs to come first because it has the higher exponent. And then plus x, and then minus 3. Let me jump down so if I can find a trickier one. Jump down to number 17. If you look at number 17, we have 7xy, and then negative 9x squared y, and then negative 3x to the third y squared minus 4. So of those, which one has the highest exponent on x? You see that it's that third one. Okay, it has an exponent of 3. Now when you move that to the front, be careful. You need to move that negative 3 with it. So it becomes negative 3x to the third y squared, okay? And then which one comes next? Okay, so when you see that exponent of 2 and you take that whole term, even with the negative in front of that term, and that would come second, and then you move the next one to the third. It looks like we're going to leave the -4 at the back. Okay, so that's kind of the idea. It's not too hard, but sometimes it just takes a little explanation to understand what these new algebra terms mean. Okay, do a good job on that. We'll see you in a few more pages.